found himself like a schoolgirl.
Yes, I remember
Thanks
my
to
first
IO. So yeah, we are on day 3 of the IO chapter of 7 Languages in 7 Weeks. And this is the chapter where things get a little bit more interesting and exciting. Tim doesn't like interesting things. He sneezes at them. So one thing that IO tends to really excel at is doing DSLs inside your program. So a DSL, as we all know, is a domain-specific language, which is basically just a language that's closer to the problem domain at hand as opposed to the natural semantics language gives you. And IO is great for that because of its flexibility and stuff. And he gives an example here, which we aren't going to go over, but apparently there's an implementation of a decent subset of C that takes about 40 lines of code in IO, which is pretty exciting if you've ever written a C compiler, which I haven't, so it's not very exciting. But anyway, that's a bit deep of an example for what we could go over in this chapter. So we're going to do something like parsing this out, which is similar to how an object looks or a hash looks in JSON or JavaScript, which IO doesn't support natively, as we learned from the last chapter. It uses the map prototype and just has @put methods to do things like that. And there's 2 ways you could do this. You could either parse it, which is what I would probably more immediately jump to in most languages, or you could define a construct so that IO is able to interpret it. And that's more interesting and a better demonstration of what IO is capable of, so that's how he tackles the problem. So yeah, in only 8-ish lines of code, he defines the ability to express a hash as that. And we do this by adding a colon operator, which will just override colon to call the @putNumber method. And then we override curly brackets, and curly brackets is a method that IO gives us that it will call whenever it encounters a curly bracket. Go figure. It is usually defined to is not defined, usually, but if we define it, then we can take advantage of it. So, moving along. He goes on to break down this code example a little bit better. Yeah, so, as stated before, whenever a colon is encountered, IO will parse that as @putNumber, and actually it will interpret that as @putNumber, I think is what he meant. And it will say that the first argument is the name, which is a string, and the second will be the value. And then it takes that, and so if we do key value, we parse as @putNumber key, value. And then here's his definition of the curly brackets method. What this does is, off the bat, it creates R, which is just an empty map or hash object. And then it iterates through each argument that is passed to the curly brackets method. And it does do message on them, which is similar to a val in Ruby. Oh yeah, those are do message arg. So that'll call @putNumber with R as the receiver and pass the arguments into @putNumber, which will then, and I thought this was kind of a silly example, is he made it so it looks for a phone number and strips it out and turns it into a number, but it doesn't really add much to the example other than a little bit of unnecessary confusingness with this, because oh wow, I'm doing a terrible job explaining this. You all read the chapter, so you know, right? Basically, this just gives a good example of when you try to mutate an arg, you can't actually do that because the arguments are immutable structures. So you have to call the asMutable method on them first. and then you can do things like manipulate the string. And in this case, he strips out the quotes since it's already a string to begin with. Yeah, which is what that says there. But yeah, so basically that just lets you build up JSON-style hashes with I/O in a very minimal amount of code. It's like 10 lines of code. It's kind of cool. You can define a completely new language construct that way. Blah, blah, blah. But yeah, so you can redefine anything from operators to symbols, so it makes it a very good language for building up DSLs. Break. Next, we will cover I/O's forward message, which is very similar to Ruby's method missing. And if you're not familiar with method missing, what it will do is in Ruby, if it does not encounter a method further up in the callback, in the inheritance chain, then it will at last go to method missing, and if method missing is defined, you can override the behavior of missing methods. So instead of just blowing up, it can do something interesting or useful and make things difficult to debug. But yeah, he says that the stakes are a little higher in I/O because it doesn't have classes, so changing the forward changes the behavior of any basic things. I don't necessarily agree with that, because the only way that would be more dangerous is if you overrode forward on object, which would be the same as overriding method missing on object in Ruby, which you would never do.
Unless you're writing the first version of our spec.
Unless you're writing the first version of our spec. So if you want to write the first version of I/O spec, forward, overridden on object. But yeah, so as long as you're properly using prototypical inheritance and stuff, I don't see why using forward is any more dangerous than using method missing. The example he gives for using forward is for building an XML builder, which is not dissimilar to Ruby's builder. And you see within 7 lines of code, he manages to make it so you can define, whoa, go away, don't want you. Okay, so you can define markup like in this style here instead of doing the full XML, and it'll expand out and make it come out like this, much like you would expect it to. And the way this works is it introspects the, so first of all, it overrides forward on this builder object, which is just a clone of object, so it's just a blank slate sort of object. And it'll write a line that prints out the message name, which, so like for UL, the message name would be UL, go figure. And it does that inside opening brackets, and then it evaluates the contents, and then it finally prints the closing brackets with the message name again. So it's pretty simple, and you can see how it would be useful. Yeah, another cool thing, which I hadn't really thought of, is if you've done something like this and you want that behavior to be across the board, you could override the clone method of object to clone this new object that you've defined. So any new object will behave like your new base object without actually having to open up object itself, other than to override the clone method. But once again, that's probably not something you would generally want to do. Concurrency. I didn't find this portion as interesting. So,
It was very interesting.
T-Pope, why don't you tell us why it was so interesting?
Well, it's been a while. But I mean, this is when we were sort of getting around, hey, look, you can do some stuff we do in other languages in a slightly clunkier way. But, hey, look, you can actually do something new and stuff.
And instead of using threads, the main concurrency construct of I/O are coroutines, which all fire asynchronously and are better than threads because they can't mutate each other and other reasons. anyone want to expand upon these? Coroutines are good if you need to do things asynchronously.
Do we know if I/O is being used somewhere in the wild in
It is.
productions, in production environments?
It is.
Like any examples?
Pixar was supposedly using it. I don't know for what though. And it's typically when it's found in the wild, it's on embedded applications because it's got a small embeddable code base and
That's right.
good support for calling out to C. So that's most of the real world cases that exist. Yeah. Coroutines. You can read the specifics of it if you're interested in it.
Basic.
It just makes it really easy to make things asynchronous. You pretty much just put an @ symbol in front of whatever the message name is, and bam, it's asynchronous. It's kind of neat. I think F# has a similar construct, if I'm not mistaken. And maybe Scala, maybe. And then he gets into actors, which are built up from that primitive coroutine. And an actor has huge advantages over threads. It changes its own state and only accesses other actors through closely controlled queues. And they, as a product of that, are not subject to race conditions as threads are. So, like multiple resources couldn't access the same coroutine at once. They're kind of encapsulated. So yeah, to make something an actor in I/O, you just simply send it an asynchronous message. That's it. Becomes an actor. It's kind of cool. Yes, Ro.
Oh, I was looking at the. Yeah. Oh no, I mean, this is pretty cool stuff. Stuff that we can.
Yeah, it's cool, but I don't know how to talk about it.
Right. It doesn't unless you have like a specific problem that you're trying to solve that needs to run
Right.
concurrently, then it's just very hard to just say, hey.
Like, yeah, I totally need these strings to print concurrently.
Yeah.
I wish we would have given a harder example. Well, then this one's a little bit more useful. Futures are, instead of returning a nil result immediately like coroutines do, futures will return a future object, which should you try to evaluate it before it is available, then it becomes blocking. So as long as you don't try to evaluate it, it's non-blocking. So the actual firing of the action doesn't block, but then when you try to use the return result, it becomes blocking then. So you can, if you try to get the value of a future, it blocks, and if it's not available, and if it has returned, then it is no longer a future, it just returns that result object, whatever it may be. So like for this example, he fetches a URL and does something else while it's going on, and then accesses it, at which point it becomes blocking, and then it finally prints. But up until the point where you try to access it, it would be non-blocking. It's kind of a cool approach to asynchronous processing though, as opposed to like something like JavaScript where you're just caught in callback hell, and it's nearly impossible to unweave once it gets deep enough. So, day 3. Wow, this chapter needs to go slower. You guys need to talk more. You guys need to have questions. All, however many of you. So yeah, for day 3 self-study, I only did one of these because I suck. But I'm sure everyone else here did the rest, right? Okay, great. The first task to give us is to enhance our little XML program that we saw earlier to add spaces to show the indentation structure. And I'm pretty sure like how you would do that is you would just introspect the number of arguments, and then based off of that, multiply that by, like figure out each one's stack level and then do that number of spaces before it, right? Times 2, probably. I didn't actually
That would give you
go
a
through
2
it.
space indent.
What?
So that would give you a 2 space indent.
Yes.
That's why you multiply by 2.
Yes. Thank you, Tim.
Trying to help you riff.
You were good. That was good. So yes, if you multiply it by 2, it will give you a 2-space indent. If you multiply it by 4, it will give you a 4-space indent.
Yeah, that works up to 8.
Yes.
What about tabs?
You can multiply it by tab. And then everyone would hate you. The next task he gave us was to create a list syntax that uses brackets to define a list. And I thought this was super cool because it's like the smallest line of code ever. So to do this, you just override square brackets. And you do oops. What is it? Arguments. And then you can do, hey look, and then it's a list. It's so tiny. It's like 4 words to define syntactic sugar for defining arrays with brackets. Yay.
Pretty good.
So yeah, I did that one. And then the other thing he tells us to do is enhance the XML program to accept attributes. I didn't do that. It probably wouldn't be that hard to do. It might be. I doubt it.
Depends on who you are.
Depends how awesome you are. I mean, if you're Row, piece of cake.
Take years.
Piece of cake. Wrapping up I.O. We have 30 minutes left. We shouldn't be wrapping up yet.
It's okay. It's no, you know.
We can go back and try to work through the examples and look like jackasses online. That'd be fun.
There's nothing wrong with that.
So, in summation, I.O. is really powerful in that its syntax is so simple, much like the Lisp language. This was touched on earlier, but when things are so simple like this, it makes it for a really flexible language and it has all sorts of benefits that are not immediately obvious as far as being able to redefine things and things. It's also very easy to grok initially. Strengths, flexibility. It's got a tiny code base. It's easy to embed. The syntax is very simple. It's very easy to learn. It's very flexible due to being duck typed and dynamic and all that jazz. Strong concurrency constructs. Weaknesses. Due to that simple syntax, it makes it very easy or very difficult to understand things at a glance because you actually have to read through and process everything versus, for example, he gives, if you see a bracket after an array with -1 in Ruby, you immediately know that's just going to return the first item. Whereas last item, rather.
The first at the end.
The first time.
Yeah, so it makes it easy to see things at a glance and understand what they're doing. Whereas with I.O., you actually have to read out and sort of process things and follow them up. So while easier to grasp initially, once you are using it full time, it becomes more difficult. Maybe. Not more difficult, just less easy.
Harder to swallow. Because that's what the syntactic sugar was.
Oh.
Mary Poppins.
Ferris Bueller,
Ferris Bueller. Hard to
Just
swallow.
rattle.
And he's always swallowing things.
Yeah, like when he eats and stuff.
The Sausage King? Is that what they call him? The Sausage King of Chicago? Nate Kroger?
And Hashtag Book Club has gone there. The I.O. community is pretty small right now, so that's sort of a disadvantage if you are trying to do a big project in it. There's always that chance that it would just poof, disappear. And if you're looking for developers, you'd probably have to, they probably would not know I.O. coming into it. Performance, because of its dynamic nature, it tends to not be the fastest language around, but given its concurrency constructs, depending on the task at hand, it can still be very performant. Final thoughts. He liked learning I.O.
Yeah.
I did too. It's cool. It changes how you think about things a little bit. So that's really, if you're not gonna actually be using a language, if it just makes you reflect on your current languages a bit differently, that's probably the biggest benefit you could take from it. I don't think if you learn Python and you're a Rubyist, you're gonna go back thinking too much differently about your original language because they're just so similar. Whereas with something like IO or Haskell or whatever, it's just
I thought you said Pascal.
or Pascal,
Sure.
Pascal or whatever.
At the start, didn't he say that
Delphi.
this helped him understand JavaScript better?
Mm-hmm.
'Cause it was like a more pure.
But yeah, it's a pure implementation of prototypical inheritance.
Going back to the roots.
What do you guys want to do? You want to keep going, or do you
Yeah,
want to
let's-
try to work through the
Let's
examples?
stare.
You can stare.
No,
I still have half a beer.
It was. I think the idea was that we dedicated enough time to I/O in both sessions, and maybe-
Shall we go around and
No.
put forth our final thoughts?
No, I do want to know though.
I like-
If anybody knows, or can anybody think of because I learn when I have a little project or a little excuse to learn a language, then it's way easier for me to dive into it, And I was just thinking, what would be a good, practical thing that you could implement in I/O?
Another language.
Well, I mean,
A recursive descent
Or
parser.
eyeshadow.
Go.
Shad in
Multiple
parentheses.
levels.
I don't know. I think any problem that you could approach with Ruby, unless you're trying to take advantage of Rails, you could just as well solve with I/O. It probably doesn't have quite as strong of scripting facilities, but it still has them. So I don't see why.
Yeah, I'm just thinking.
Maybe the next time you want to write a little command line utility or something.
Yeah, like scripting or
Yeah.
something, even the dirty.
Or like a little server. Or
Yeah, I was just maybe food for thought for
If you want to write Rails for I/O,
there you go. Write your own.
you could call it Roheel I/O.
Yeah. Actually, I was thinking of doing it. I was thinking of doing like an artificial intelligence called IA.
It's like AIO.
Intelligence
IAIO.
Artificial. And then it's implemented in I/O. That's why it's called IA.
Oh, I thought it was because you were foreign.
Oh, I get it.
Aww. So, in addition to being sexist, book club is now racist as well.
There you go.
Woo!
We have to say to the camera, you're still here because this chapter is on Ferris Bueller.
Oh,
You're
yeah.
still here?
Go home.
Yeah.
Oh yeah, damn it!
Mr. Chance.
Alright, anyway, we're done.
We're gonna call it. Anyone else wanna? Cameron, you look like you have a lot on your mind.
I do have a lot of my mind. I was here in person though, if not in spirit.
What did you think?
I meant a lot on your mind about the chapter.
No.
Okay. Well, that was a quick book club.
It's okay.
We'll see you next week, probably.
Next week is
Oh,
prologue.
prologue next week, which
So-
Ro will be hosting.
Sure, yes.
Prologue.
You can't spell prologue without row. Log. Anyway, see you guys next week. And why are you still here?
Keep it.
Go away. Go home.
I could be